Greetings everyone, time for a video about this Micsig CP2100A AC/DC current probe. I had a video not too terribly long ago where I mentioned and showed that I picked up a Micsig oscilloscope, decided on that, discussed in that video. You can see a link wherever. I think I've got one in the description below, or a card, whatever. Anyway, I've been looking for a few other things, because when you buy an oscilloscope, you buy other stuff. So in this particular case, I decided I wanted an AC/DC current probe. I already have another one, which later on in this video, I'll do a quick comparison between that one and this. This video is basically going to be just kind of a brief overview / unboxing. There's other people who have done videos far better than what I would do about it. And I'll put some links in the description below to others who might, you might have, might want to go check out what they have because they get into some good detail. But I figure I'd cover a couple things in this. And so I picked this up, came in today. I ordered it from Betronics. I think I'm pronouncing that correctly. They're a seller out of Germany, electronics dealer that sells, probes like this, oscilloscopes, Rigol, Keysight, Micsig, so on. They had a pretty good deal, and even with the shipping, which I'll tell you something funny about the shipping in a second, I got this for a pretty good price. Ironically, or I guess oddly, I had this shipped DHL International Express, and it got here, I think, around 6 days from the time I ordered it. Surprisingly fast, and given how terrible things are right now with the Postal Service, and then other shippers are having some problems as well. It was really impressive that they came from Germany to here in about 6 days. So anyway, enough yapping, let's open it up. This is how it comes. This is the box. Nothing really special. Then this is the Micsig box, as you can tell. This is how they provide it, and then you open it up and you get the this is the box itself, comes in case, and then Betronics, they throw in their stuff, a little bit of paperwork. This is what you get. It's got a little case, hinges, plastic. It's pretty straightforward. It's not bad. It's nice to have one, though we'll say maybe not, because maybe you're going to put this in something else. At any rate, this is what you get. You get a warranty card, nice little foam, top and bottom. This is kind of flimsy here, but yeah, whatever. This is a USB cable for powering it. I'll talk more about that in a second. Nice little foam insert, kind of a hard foam here. Get your clamp. This is an AC/DC clamp, which is nice. It has a 10 amp range and 100 amp range. And you have 0, and then of course you can manually adjust the 0 point on this. They have two versions of this. This is the CP2100A, and then they have the CP2100B, which has a larger range and a higher bandwidth. The fascinating thing about this is partly is the price. This is considered to be a pretty high quality current probe, and in fact, I think even Dave from EEV blog, I don't know if he reviewed this one, but he certainly has talked about their stuff and said he's spoken pretty highly of them. They've had interface quirks on the oscilloscope, which is a different thing, but so far they've seemed to have done, they've produced higher stuff. They're good value in some areas, like this is good value for the quality, and other reviewers either on YouTube or online, if you go dig around, they've said that this has pretty good accuracy. So as I mentioned, I'm going to do in a second, I'm going to do a comparison between this and another an ES697 AC/DC current probe. You might say, oh, you already got one, why buy another? Well, there's a few reasons for that. This one, as I said, is pretty high quality, but for the price, it's pretty good. When you really want to start getting into higher quality or better bandwidth and good range, you got to start paying some money. I mean, I was kind of flabbergasted at some of the costs for some of the current probes out there when they start getting into thousands of dollars. So for this being, you know, a couple $100 depending on where you look at, it's not too bad. And you can go cheaper, and that's okay, but you know, you want some decent quality. This is, you start looking around, and this is showing up as being pretty decent. So, like I said, you got the clamp, you got the BNC. This has an interesting piece because the clamp goes into this unit, which is where you can pick the range and stuff. And then it has a USB port. And one of the differences between this and other clamps, or I'm sorry, other current probes, is that it's powered from the USB, which the oscilloscope, the Micsig, the one I bought, has USB ports, so you can power this probe directly from it. There's a problem with that, which we'll talk about later, but it's nice because, you know, most of them you get like a 9-volt battery or maybe AA's or AAA's, and that's fine. But sometimes, you know, it'll die when you least expect it. My other probe actually hadn't used it in a while. Sure enough, the battery was run down some, so it's kind of a bummer. And I've actually had a 9-volt, so I got to go pick up a 9-volt battery just to go and run the test, which ought to give kind of a good argument for Micsig's approach, honestly, because you can drive it from just a standard 5-volt USB charger, or you can plug it into the port on the Micsig oscilloscope. But there is a downside to that. If you have multiple probes or multiple things you want to drive from that, well, it's kind of a problem, right? Because you can only drive one. But the other thing that's rather interesting about this is that you can also drive it from a battery pack. So like if you have, and I'll pull one out, and actually I'll probably drive this from one just to show it when I do the comparison. You can get one of your standard battery, battery packs that you can take to charge your cell phones and whatnot, and plug this up to it. So you can bring a couple of them and have plenty of runtime. It's kind of an interesting feature, I think, that puts this kind of separate from others. At any rate, I'm going to go ahead and get set up for that, and I'll pull the other one in and bring you back in when we're ready to do the comparison. Alright, I'm back. It's actually been a bit since I started this video, and I've had a couple of things I want to cover, as well as something I want to point out. I was wrong about two things. First is I just said a minute ago, or in the video, that this is the A version, right? The CP2100A. They also have the CP2100B. I know one difference I pointed out was that the bandwidth was higher, but the other difference, which is the rise time, actually, but I misspoke and I said they had a different range, but they both have the same range. It's either 10 amps or 100 amps. So the big difference is really the bandwidth on the B version, which is higher, as well as, of course, the rise time. So I wanted to correct that. The other thing, I've had some time to play with this and actually have tested it out a bit. I mentioned before about the USB, that it's great that it has it, but it's kind of a problem because there's only one port on the oscilloscope. But I missed this, which is that, I don't know if you can see, there is a USB-A here, and this is actually an output according to the manual. And what happens is that you can actually daisy chain these together, like say you have two of these probes, or maybe you have a probe and say one of the differential probes or something else. Now I still think there's an issue, but it's actually a nice little feature. So in that regard, it was pretty good that they thought about it. I didn't say anything though about how many you could chain together, because eventually the USB ports are going to get pulled. I don't know, maybe this is pretty low current. Can't say, but it is a nice thing, and it's something that's a plus. Now, I want to go back and revisit the case. Like I said at the start, the case is fine a moment ago, but I thought about it a bit and messed around, and I realized that this is great. At the same time, it's kind of meaningless, and in fact, it's probably bad that they included this because it's a bit wasteful. The reason I say that is, you notice I got this cutout, which, okay, it's cool, but it's not cool, because if I'm using this, I'm going to pull it out, right? And then I'm going to go undo the Velcro, and I'm going to run the lines, I'm going to run this. I'm going to run the current probe somewhere itself. I'll have this hooked up. Now when I'm done, I got to go and I've got to put this back in. All right, now I haven't taken any of these things apart this minute, but you can even see as I'm trying to put it back in. Sure, I can fit it in, but if I'm using this off and on, I don't really want to have to go and deal with that, honestly. It's kind of a drag. And the other negative about the case, again, I'm not knocking their quality or the fact that they did this. I appreciate that. But in terms of use, it's takes up, other than, of course, the fitting, it takes up a lot of space. I mean, this is big. You know, it's a huge amount of space, and I'm not going to carry this around. I really just want to have the probe, right? That's kind of the whole point behind, even here, as they show in the picture. This thing's very portable, which is a plus. So this case does not lend itself to that, and that's why I kind of think it's a bad idea to have it. So to that end, I went and I noticed that you can go and, you know, like I can get this little bag here. I picked it up on Amazon for, you know, a little nothing, and oh hey, this is how hard it is to store it. Okay, this is the better way to do it. In terms of just general use. And then if you even look in terms of space, now let me zoom out a bit. I mean, you can even see it takes up, yeah, maybe 40%. I mean, this thing can really compress down, and I really didn't bother to probably wrap this up as I could have to make it save less space. I just took it how they normally have it and put it in there. But even then, this, you know, you throw this in a bag, you throw this on your shelf, it's real easy to store. While this is just not. So that's my opinion, but this is what I'm going to do. I have a bag where I keep my oscilloscope in it, and I can just throw this in a part of it, and I'm done. And this just isn't that. So I'm going to go through this in a box, and you know what, and so on. Anyway, back in a moment. I'm going to set up a test, and then we'll start doing comparisons, as I said earlier. All right, I'm back. This is just a quick overview of what we're going to be using to test. Obviously, the primary focus of this is the Micsig Current Probe, the CP2100A. I did mention before we're going to do an ES697, and we're going to use this for both DC and AC tests. And then I have this AEMC MN114 AC current probe. It only does AC. So when I do AC, this one's going to come in. And then finally, kind of as a control, even though it's a really cheap, inaccurate meter. Wow, I say that. It's just pretty inexpensive. We have this Unity UT210E. This will be just kind of, hey, this is what we're getting. Let's see how the others compare to it. This really isn't a comparison in terms of accuracy of, hey, this signal is the best. You know, this probe is the best, producing the best signal or whatnot. It's just to give you a rough idea of what you're going to get. Just keep in mind that these are not apples to apples. You know, like this, for example, has two ranges. It has a 0 to 40 amp range in both AC and DC, as well as a 0 to 400 amp range in both AC and DC. I picked this up a while back, and I kind of wish I hadn't. It's not, the range is just not something I'm ever going to need, but it's relatively inexpensive, and it's, I mean, it's been fine for what I've used it, but I already, just based on what I've seen, I think I prefer this one more. Also, this is a multimeter style clamp probe, but you can use it for oscilloscope with the right adapter and the right settings, as we'll get to in a minute. Same thing for this. This is really, this was just something I was buying a bag. They threw in some extra stuff off of picked it up off of eBay, and this happened to be included in it. Got a good deal. Picked up, they had to throw a bunch of extra stuff in for a multimeter bag, and well, I've got this. I've never really used it much, but and it's really meant for low current because the range on it's only 0 to 10 amps. But we'll take a look at it and see what we can see. And then finally, of course, the UT210E is just your basic, inexpensive multimeter, but it has its uses. Big Clive had this, and I said, hey, you know, he mentioned that it has one plus and that it can easily do DC current through the clamp, and I picked it up too, and that's actually been a pretty handy feature. So anyway, I'm going to get set up to do a DC test, and we'll be back shortly. All right, I've got everything set up for our first DC test. I've got the Unity here, and then what I've got for the circuit is there's a 12 volt battery. I've got two 10 watt rated 10 ohm resistors in series, which means we should roughly be seeing about 0.6 amps current. Since this is 12 volts, might be a little higher because this battery is charged a little higher. For the setup for current, I've got, like I said, I have the meter. I have on channel 1 on the oscilloscope is voltage across the battery. Right now it's 0 because I don't have the circuit completed. The Micsig is on channel 2. This is in current mode. Got a 5 amp scale. I've got measurement down here. And then I've got the voltage on channel 1 shown here. And then I've got the ES697 on channel 3. If you remember, I said you had to have the settings right. In this case, it's 10 millivolts, produces an amp. It's very noisy, and what you do is you get these converters. Like I've got these are kind of stackable ones, but they run from these into the B and C into channel 3, and that's how you can do it. And of course your settings have to be right. This does work, but at such a low current for this, I'm not expecting too much, especially compared to the Micsig, which is in 10 amp mode. So 10 amp mode means it's a 10x in the Micsig. In the case of, there's a chart in the manual and the Micsig scope where they show you the attenuation, so you can figure it out. In this case, this thing should be 100 to 1. Or 100x, sorry. So let's turn this on. I'm not going to run this long because these things are dissipating about 8 watts each. They get hot quick, but this should give you a pretty good idea of how this works. So we got it going, and we're getting about 0.58 amps DC on the Unity. 12.8 volts, like I said, it's a little higher than 12. I'd just charge it up. 700 milliamps, which is pretty close, a little higher, and we'll come back to that in a second. You kind of see something here on the yes, but if I take it off and I go back, you kind of don't see a difference. I mean, it's sort of floating around 1.8, but then you'll see it float up. This thing's kind of wobbly. Notice that the Micsig, for whatever reason, it's showing 100 milliamps. So if I go and I put complete the circuit, it jumps up to 700 milliamps. So if you do the difference, that means you're getting about 600 milliamps, which means it's actually measuring the amplitude probably pretty well. I mean, this thing's showing, 579, 580 milliamps. So it's really close. And it just could be the setup and how things are. But apart from that, it's coming up pretty well, especially for such a low current. I'm pretty pleased with that in terms of that. One other note, I'm also, when I'm powering this, I'm actually using a power bank, just a standard power bank that you can get. There's lots of them for charging your devices and stuff. And I'm running it from that, not actually from the scope. I could run it from the scope, but I'm just not for the purpose of this demonstration. Anyway, so as you can tell, that's how this works. It does pretty well. I'm going to do another test real quick. I'm going to pull in another thing. And so let me get that set up, and then when we have that, I'll bring you back in and we can go forward with that test. All right, next thing, which I'm going to set up in a second, is we're going to test this DIY smoke machine that I made some time ago. If I remember, I might put a video link in the description below on many ways to make this. I use this to try to diagnose evap leaks or vacuum leaks on cars. You run your air in, just a little bit compressed air through a restrictor, so you're not really blowing out too much. Hook it up to the battery. Inside is a heater wire that's run in a coil to produce some heat, and you have like a kind of a wick and some oil that will burn and produce smoke, and with the compressed air it comes out this end. So I think the resistance on this, if I remember right, is about 4.3 ohms. So we'll get a much higher current, and I can run this instead of running the resistor. So we should be able to see a little better output, so we can see it better on the scope. I'm gonna get that set up. I'll be right back. All right, got it set up, ready to go. You already see I've got 12.8 volts. Again, channel 2 is Micsig, channel 3 is the ES. We'll see what we get here, and we're hot. I gotta set the unity up to next amperage setting. So we're running about 5.5 amps, and the Micsig's running saying it's about 6. ES is doing better. It's saying about 7 to 8 amps. So yeah, it's reasonable in terms of what it's producing. I just kind of moved over a little bit, but it's, you see it kind of floats. So not too bad. We're getting about what we would expect to get. Maybe if I change the scale a bit on, we might get a little better. Yeah, we're getting a lot better accuracy in terms of what we're seeing on the Micsig. Let me see if I change the scale on. A little better too on the ES, bumping it down to a 5 amp scale. If I do a 2 amp scale, it gets real noisy. But it's a little closer in terms of accuracy. So 12.2 volts running through here, and this thing's going to really pull on it some, so it's going to pull it down a bunch in terms of the voltage on the battery, because this lower resistance, so it's going to pull more current. Apart from that, everything looks pretty good. Pretty happy. There's a slight difference in terms of what the Micsig, the Unity is saying, but not terribly different. Still, currents, I'm pretty happy with what I'm seeing. Of course, you notice the difference in noise. The ES is just super noisy. I mean, you're getting somewhat of what you would expect, but you know, it's a little bit all over the place. Meanwhile, the oscilloscope probe that's just pulling, you know, the passive probe that's pulling voltage, and then the current probe, the Micsig, are very smooth. And of course, you know, the Unity is going to show that too. Anyway, that's it for this test, and this will be it for the DC test. It's pretty much all we can really do here. I don't really have anything that's going to produce a lot of current other than, say, hooking up to an alternator. And I'm really going to go do something like that. I do have, I actually did use the Micsig to do an alternator test and to diagnose, and then I later on replaced my alternator in my one of my cars. So I'll put a link in the description below. I'll see if I can pull a time code so you can see where I was using the Micsig, and it was working very well for that. So anyway, next up is going to be the AC tests. We'll actually have all of these plus the AEMC MN114, and we'll see what we can come up with for a test for that. So when I get that set up, I will bring you back. Alright, I'm set up for AC test. I've got the Micsig in 10 amp mode sitting off here. Channel 1 is the Micsig probe. Channel 2 is the AEMC probe. Channel 3 is the ESI probe. And then I've got the this Unity current clamp meter set in 2 amp mode. And what we're going to use for test for this first test is a 100 watt incandescent light bulb. Yes, I still have a few of these left. So you'll see it come on. I'm not sure that we're going to pick up much in terms of signal. After all, this is kind of a pretty low in terms of what we're going to see. It's just you're not going to get much current out of this, but we'll see how it goes. So let's turn it on and see what we get. And there we go. So let me go and change the scale a bit here. The problem with this is it's so noisy that it's hard to see it. It starts from the ESI, it really starts overriding. So we're getting around 0.8 amps or 800 milliamps roughly. And Micsig showing 832. The AMC showing about 850, and sadly the ES is showing about 1.2 amps. It's just not quite right. This thing's really, honestly though, that's really just pushing the limits of what this thing can really do. Let's be frank, it's really meant for larger currents. So, I mean, it's nice to see that it's picking it up, but it's just not going to pick up much. So I'm going to cut it back off, and now the ES drops down to 700 milliamps. So, I mean, if you added it up, it's probably registering about 500 milliamps or so. Not too bad. You know, just that you've got this offset, and I mean, even you're not really shouldn't need to zero it, but even zeroing it just doesn't make a difference really. And yeah, I know I'm supposed to zero it off, but even if I do that. It's really meant for DC 0. It even says so, though it does have a little effect, but it's just not going to pick up anything other than what it is. That's just how it works. So let's see, we'll try again just to repeat the process one more time. And here we go. Nice current flow. Again, around 807 milliamps according to the Unity. Frequency 60 hertz, so that's good. And then 832 with the Micsig, 852 with the AMC, and then about 1.1, 1.2 from the ESI. So that, pretty much not bad. Plus, I'll also say the Micsig's got a really clean signal at this scale of just 1 amp. You can see some noise. Let's turn the ES off because there was a little bit of noise bleed over its signal into the AMC. But AMC, you see, is kind of noisy. It's kind of a little fluffy, I guess you'd say. And that's just the way it is. I suspect. Let's see if we switched it. We made it. Yeah. I mean, you can tell it's got some noise, and there's not really much you can do about it. If we scale it horizontally, I mean, you can see how it's just kind of, yeah, it's not nice and defined like the Micsig is. Anyway, so I'm going to go ahead and I'm going to set up for the next test, which will be hopefully a higher current, so we'll see something more defined. We'll get that set up and I'll bring you back. Alright, I'm back. Have the next test set up. I've got this Wagner heat gun plugged up, running through. So in the corner you can see I've got the Micsig, and then I've got the AMC, I've got the ESI, and then just kind of as a control, I've got the Unity meter set on 20 amp range for AC current and current clamp. In terms of channels, channel 1 is the Micsig, channel 2 is the AMC, channel 3 is the ESI. I've got frequency on, and then for the measurements on each one, I've got RMS set up for all of them. So let's see what we get. I'm going to run this. I think I've got it set to run at 400 watts, so you're going to hear some noise. Sorry about that. But when this thing comes on, it's going to turn on the fan. So, and we're on. And I'm going to see some jumps for a minute as it heats up. So this will heat up, and when the element gets warm enough, it'll kind of switch into kind of more maintenance mode. So you'll see some spikes and stuff early on, but as you can tell, like right now, we got 4 amps, and then it dropping back down. Micsig's measuring pretty good, and you'll see some jumps, and then 4 amps for the AMC, which is really good. The ESI is not doing bad. It's up to about 4 amps too. So they're all pretty much in sync in terms of reading current, which I'm pretty happy with. Now, it kind of takes some futzing to get the settings right and all that. I've got the Micsig set, and this is actually set in 100 amp mode. If I try it, I think I've tried it before in 10 amp mode. I think I had problems with it. Yeah, because what'll happen is it's actually, there's transient spikes that are occurring in this that aren't part of RMS, and it'll actually exceed the range of the Micsig, and it'll switch into warning mode. It'll start beeping, and then when that happens, what it's saying is, hey, this is exceeding the chosen range you have. So that's why I have it switched into 100 amp mode. But run an RMS, and it'll pick everything up pretty well. If I go and try to increase, actually I had it set to 200. If I try to increase it, let's say we go up to 400 degrees Fahrenheit, you'll see the current go up a lot higher, and then it'll start dropping back down as it'll turn on the heating element, pull more current. It'll stay on in that mode for longer, and then after a bit, when it senses that it's heated up some, it'll drop down some. But as you can tell, it's certainly running a lot hotter now. I'm going to turn this off now. Like I said, as you can see, everything's pretty much in sync, which is pretty cool. Micsig, Seems to be covering things pretty well. I'll have to go look at the tape, but they seem to be pretty well in terms of matching what each of them has. So a little surprised that the ESI is doing a little better than I expected. It's very noisy, but when you actually get a signal going through, it actually reads pretty well. It's not completely in sync, it's a little off some, but it's not bad. So anyway, I'm going to shut this off now, and you should see everything drop back down. Now if you notice, the ESI is running around 1 amp. I know that's kind of hard to see. You can't really adjust the text size on this to make it bigger, which is kind of a disadvantage. But and then for some reason, both these two are running 200 milliamps roughly. A little unusual. I've zeroed them out, but this is what they come up with, so there might be something else that's kind of out of whack with it. But anyway, I think that's about it for this video. I think I've covered things pretty well in terms of just comparison with the Micsig Current Probe with these other two, and you know, kind of getting a rough comparison to this current clamp for the Unity. It's, you know, its feature here. You kind of see how it works, and pretty happy with it. Pretty impressed. It seems to work pretty well, both AC and DC, and you know, some of the features are pretty nice. You know, the USB and whatnot. So I'm pretty pleased with it. In terms of pricing, it's not bad. I mean, I think it's pretty competitive, you know, for others, for other oscilloscope probes that are of the same quality or higher. So I think it's a pretty good deal, and I'm pretty happy I bought it. I've already used it. If you've seen my video about diagnosing my alternator on my Honda Pilot, it worked out pretty well in showing the current from the alternator to the battery, and I got a pretty good reading with that to see, you know, there was a problem. And then when I fixed it, it showed that, you know, the current was working pretty well. So that's about it for this video, and as always, thanks for watching.